Good morning, everyone. My name is Chad Northington. I'm a senior engineer with Geosyntec, and I'll be your moderator today. Welcome to session 1. We will be going over regulation, policy, and compliance in the PFAS world. I'm pretty excited about this today. 1, because we got an awesome lineup of speakers and topics, but 2, I usually moderate at the end of the day, so everybody's always hangry and want to go to happy hour. So you're bright-eyed and bushy-tailed this morning, so I'm expecting really good questions at the end, which we are going to hold till the end. So please write those down as our speakers are presenting this morning. So our first one is going to be Mr. Neil Campbell. He's Vice President of Environmental Operations with SCS Engineers, and he's going to dive right into PFAS politics right out of the gate. So, Mr. Neil.
Thank you, sir. Good morning, everyone. So, the last session with Michael's moderating leads into this in some way. They covered a lot of things, which I felt great because I did my research. That means I got it right. But I was taking a look at this, and I've been in the business as a geologist and a consultant and other, working with different factors of all contaminants for years in Florida. And we look at it with a number, which is the ambiguous thing here, right? We don't have a number. We think we have a number. And then when we look at it as a closure, right? Putting that thing on the wall, yeah, well, we're never getting that right now. So I started thinking, how does it affect, we think of landowners, how does it affect businesses? How are businesses navigating this environment? And then, we all know Florida really well, we're learning about it this morning, we got great feedback. How does it affect the world? I mean, how does the world look at PFAS in different regions? Is there a competitive edge in one place or another for a business? When you're trying to establish a business. I mean, it starts, as we heard earlier, with the groundbreaking, the due diligence, the acquisition of something to build upon. But then you're also worried about what's your process? Do you have PFAS in your process? Still, a lot of places do. Part of it was the discussion on the DOD, or the federal side. I worked for a firm that did DOD work, where we changed out all the PFAS bladders of the AFFF. And the colonel doing the procurement basically looked at us and said, not a very happy person while we were doing this, and we couldn't really understand why. And her comment was, you're just going to come back here in 5 years when they find the next batch and do it all again. It's a waste of money. So there is a lot of controversy in it, so it's kind of interesting. And so the politics in different countries, etc. So this is what's driving us right now. It's a different type of animal we're dealing with. It's persistent. We have a problem figuring out what to do with it. We're slow. We're getting there. We're speeding up. We're starting. Laboratories are developing and growing. So we're getting on with it. Earlier somebody explained, well, you have to put the regulation in place to make it happen because there's no driver. True. But you'll see through this process, there's different ways they drive it. So the point being that we had 2018 when this was first appearing in our site. I agree with Gene, there was a rise of interest and everyone trying to figure it out. And then we've had the stall in the policies, so now we're kind of slowing down again. But that's going to change. I'm sure it's going to change. So the core questions often are, if you're going to get into this and trying to navigate through this, what's the differentiator? Different jurisdictions have hugely different views on this, right? And they do it for different reasons, and it's cultural, it's a long history background. I've looked at China, I've looked at Europe, I've looked at the US and Canada and Mexico. You got to understand that some of them, and especially Europe, has had industries for several hundred years. So the United States is much more recent development in this world. So they have to look at things differently. Often people ask, can you shop around for permissive jurisdictions? Is that the best way to make your decisions if you're going to locate something or manufacture? Problem is, there's really not one. You just have to navigate through all these fragmented market decision-making processes. They're very different. The United States and Europe are different in the sense that the European Union works on group-based compounds for PFAS. So they take the whole category and then put a number to it. And then US has gone down to the specific MCLs on certain chemicals, but that's federal. The states all have their different ways of handling it. So we'll talk about that in a minute. So when I went into the literature and started doing the research, it was interesting. There was, it really comes, the advantage for a corporation or someone navigating, and this is our clients, including, before cleanup or development work, comes from looking at where the fragmented codes are and how you can adjust your business pattern to that. Doesn't mean an extra cost, it just means thinking ahead as you navigate. You may lose markets, you may change markets, but there's no one single driver that gives it a corporate advantage. Strong evidence of fragmentation everywhere. PFAS regulation stems more from governance and timing differences than disagreement for health risk, surprisingly. We all think of the health risk as being the basis, maybe here. But a lot of places it's all completely different. It's a more political statement. So on the world stage, yeah, it's a benefit to cost looking at regulatory impact analysis. Everything's different across the whole thing. You've got regulated PFAS drinking water in one country, restricted in consumer products in another. Inside the US, it gets complicated there further. We'll talk about that. And it's only addressed through monitoring and guidance elsewhere. So you've got 3 different levels, and you heard about some of it here this morning, the monitoring and guidance, which is starting now here. So we're going to start looking into that. So fragmentation exists despite the global agreement. I don't know if it's not being talked about very much, but there was a large Stockholm agreement, that was called, that all the countries came together and decided that PFAS was bad, period, no good. So you got it then listed as a consensus that these PFAS products were bad, PFAS, PFOA, and everything else. So then, as we all do in our processes, you have to come to ratification. All but 5 ratified this. And yes, the US is one that did not ratify. It's a common policy to not get tied in. The US is very good at that. So you've got these standing out of the boundary of this now, and then each country then said, fine, we all agree, but we're going to work on this on our own way, timing-wise, and scope-wise, and everything else. This is what created basically the fragmentation structure. So you have a global agreement, you have a national discretion at each country, therefore underneath, and then you've got different regulatory decisions on how you're going to do it. Because you can affect the whole economy of your country if you suddenly put a sweeping decision in place. You're going to make sure. So one of the first ones I looked at was China, and it was kind of surprising. We think China's this monster machine that just produces cells, has no environmental interest and everything else. Well, we've seen the smoggy pictures and everything else, but they've realized, as with the current situation with the oil, they've realized they have to start making steps internally to improve their processes. So their approach is really, really interesting. They agree with the international treaty, and they align with the international treaty. And so what they've done is they have stopped discharge limits from these industrial zones. So you see them on TV, but they've got these massive cities or massive industrial parks. I mean, they're hundreds of square mile type areas. So they said no discharge anymore from those parks for any PFAS products. None. So that was it. They controlled it at the discharge of that. So then it's internal to the manufacturer what they're going to do. But they then said, well, we'll follow the Stockholm Agreement, and we're going to say, just look at some of the numbers, but again, where it's going to be manufactured rather than stopping it completely. But they don't allow import, which is really interesting. I thought they would take it in as a byproduct, but they don't. So they're kind of halfway there. They've kind of done it a little bit, not fully invested. So Europe, so it started off on a scientific approach, similar to the US, and then it suddenly said, this is too much, way too much for us to handle. So they shifted. They've gone over to a more managed transition. And again, it's slowing it down a little bit, but they have maximum MCLs in America for 4, the United States for 4. They have 500, but they put it in a group of compounds. They don't single out one single element or compound out of it. So this is for drinking water standard too. So we're talking 4 here, they have 500 for drinking water in Europe. But it's across a whole case of them. So now registration, evaluation, you might have heard this, the REACH, the registration, evaluation, authorization, and restriction of chemicals. This is in place in Europe, and it's kind of like that first stage we heard earlier about your taking note, your reporting. You've got to tell me what you've got. We're going to find out what you have, and then we're going to start realizing the impact. And they do this in mind of what is going to replace it. You give you time to get an alternative in place. So it's a little different. But yeah, the scientists kind of lost their mind when they took it away, and the politicians got a hold of it. So then we go by the US, right? We have the drinking water standard we heard about, which is still being worked on or still not fully put in place. Canada does a precautionary move. It's more like 30 parts on 25 specific PFAS. So it has a higher number and it groups them together. So it has a combination of these other two. It's not ready. It's waiting on purpose. It's slowing down on purpose because it's waiting. It's watching North America. It's trying to decide what impact it has. Lower population, other factors come into play there. Mexico, I looked at them. They just basically look at specific product bans. They haven't got anything more sophisticated than that. They just know this has this, you can't bring it to the country, or a chemical reagent or something, you can't do it. So that's how they manage it. They're very early days trying to figure out what to do with it. Now I can go back to saying, I'm sure we all have clients that have worked on this. I did a little work for a company that Johnson & Johnson bought out that used to make stents. Their processes the chemicals used were incredible, massive amounts of, and so basically it was in Miami-Dade, and eventually Durham said, air emissions done, no more. So they went, all right, move to Mexico. So there's all these corporations that have done that, and now they're going to have to face something in the future, so it's going to come along here shortly. So inside the US, you've got your numbers, you've got your federal guys saying, go, this is good. Now you got your states. As with the Constitution, we're a republic. So you got the states all saying no. So you've got these different bans going on. Interestingly enough, it's food packaging is the current one that's really interesting. They're starting to say, the states are saying, you can't put any plastic or any container or the polystyrene, anything that has PFAS cannot be used for food packaging. So in certain states, not here, unfortunately, so you'll know. But as I said earlier, it's normally the Northeast and the West. It's kind of the two geographic areas that seem to, work in that boundary area. So you can't actually, the contact paper that you used to buy, you can't actually, for the big manufacturers, but wrap the apples in paper. Can't do that anymore either. So that was a new thing. So speaking to what was said earlier, reporting is now a policy lever. While they want data collection, right? They want to understand what is the problem. Up till now, it's just been obviously firefighting, AFFF at the airports and certain areas we know that have it. So now they're saying, well, before we move on, and this is in the US too, we need more information. So we're going to put in place, as Florida is, sample your drinking water. Let's find out what we got, because we don't really know. And it's sort of a pause. It's sort of a step back. Florida's done a good job on this in many ways. It's frustrating for our business maybe, but it's kind of like, let's just take a minute and think about it. So by forcing the visibility, the regulator is going to then have a defensible case for setting up a control number, number. So it reduces the asymmetry of information, and it drives the regulation eventually, which I think is what we've all been used to. But then Michael and Jorge and others, and especially in the legal profession, and Ralph, defend that because there's nothing to say they're safe when they finally say what they have. So this is the whole idea. When you're doing the manufacturing, you're trying to figure out where you are. Relocation does not equal relief from the compliance of PFAS. It's all over in different variations. So I had my little California t-shirt and my little European t-shirt, although the European guy has a weird arm coming out. But the point being is you can't just say, oh, yeah, I'm just going to find a good place, perfect place. There's no perfect place. And then the point is you're going to sell your product somewhere. So if you want to sell it in California, you're out of it. You cannot sell PFAS in California. They want to see what's in it and they won't let you have it. So those are the things you got to remember as you take this deep dive into this world. So for corporate growth and development, it's the cycle that we all know. What are all the risk cycles and how are you going to address it? Earlier they talked about how it hasn't really stopped transactions. Let's just say it kind of delays them in land acquisition, thinking about where you want to go. It doesn't stop it because you can figure out how to protect yourself. But it can create financing constraints, but then you had Edwin who comes up with the underwriting so you can then have that. We've had some recent ones where we do the due diligence work and we've had some very interesting requests like, can we have a 6-year reliance letter, please? No, you can pay me for 12 phase ones, and I'll do that happily for you 12 times. But yes, it's a very legitimate request from a financier company saying this is our new policy. We want a 6-year return. Let me say no, forget it. No way. And that actually almost caused the deal. They were that stubborn. So we had to rewrite some language. This is the consultant side. We had to rewrite and agree to some language. It was pretty tough. You have insurance exclusions sometimes. He didn't say he covered everyone, so you have those that they mess things up. And then you have stalled development, because now what's happening is you're starting to find some of the contractors are a little nervous about this. So it gets a little tricky, so I'll talk to that in a minute. So when you get to Florida, I wrote it up here, it's a case of managed ambiguity. They've done a fairly good job at putting steps in place, but we're not going to run as fast as everyone else. They're hanging back watching the federal government see what they're going to do first. But they're also then focusing on the core areas of the firefighting foam and the biosolids. Right? But now you're hearing that's getting pulled back. So they're looking at, hey, we can do this for the public right away, do the drinking water right away, but they're not going to jump into everything else, because personally, having done this for 30 odd years in Florida, they've made those mistakes before. They've gone in too fast, they've not thought it through. My initial argument for Florida was, you can take a biopsy of my liver, you can take a biopsy of my thigh, like they do with the space guys. Go ahead, tell me what I've got in me. I looked it up. Apparently, we're all carrying 1 to 2 parts per trillion. I thought that was pretty damn low, considering what I went through with Scotchgard and everything else. So Florida's being a little sensible about it. They're not pushing every single thing into the front. So I just definitely have a position on that, in the sense that I've worked with certain PFAS sites, and it concerns me, but general contractors have used the phrase to me, and it's also, one of my colleagues has written it up in an article you can look up, that they call it the new asbestos, because they can get dragged into it when they're hauling dirt on site, right? It's not necessarily Florida, we have pretty strict rules, getting a lab test from the quarry, but do you always put PFAS in the lab test? Don't know. So they're starting to say things like that. There's in some articles. I think one of the things that, if you want to look at where there's the greatest risk, I don't want to go into it because it would be too long. Go to the U.S. Chamber of Commerce site and look up what they're doing about PFAS with existing manufacturers, existing businesses that are going to be impacted. And it's everything. It's from automobile down to clothing to bouncy balls it's incredible. And they have a list of all the sites and facilities and types of manufacturing they cover, and they've written several letters to Congress explaining the impact. So it's kind of clever way of doing it, but it's hidden from me because they didn't come to me, I'm a consultant. But there's a lot of activity on that level to not have to then uproot and move or close. So there's a lot of angles coming in and hitting Congress, and we heard about one of the bills going through Congress now, landfills, which I'm SCS engineers, we're heavily engaged in landfill work, so we're very familiar with that impact. The other thing I want to add at the end, with this ambiguity comes a problem that, it's deliberate sequencing, right? You can get through it if you know exactly how to form the path, and as the room is full of engineers, scientists, and consultants, the consulting part is helping them get through this process. It shifts your costs. You have to make your client think differently, like how they're going to you don't know what they do inside the box. where you can do it, you have to help them think through this. And it's a team. There's insurance, there's attorneys, there's financiers, there's a whole bunch of stuff. But you play a role in it too. Because you are, the question was, has anyone, to the insurance, do you have consultants in the room? Yeah, you need to be in the room. It's really important. But one thing I want to say, make sure you've done your research. Make sure you're speaking well. I mean, I'm involved in one situation where I represent someone. They never hired an environmental attorney, but they sold a large PFAS property and developed it and said, I'll put this much money in escrow based on one consultant's assessment of $3.2 million over 5 years. I said, that's just a large petroleum site in my world. It's, when you look at it, then they went in, designed it. It's designed basically for massive carbon capture, pump and treat. And when they looked at it, they said, maybe 9 years and 11 million? And I said, well, you've only got 3.2 in escrow. So what are you gonna do now? Oh, I don't know. And of course, then the former owner, you would agree, he's probably gonna get a phone call and have to deal with it. But at the same time, I don't think the consultant did them any favors when they did the assessment and design. It went through the regulatory review, but as the regulators are, sure, you did enough wells, you did this, the bare minimum. There was no commentary on, you're crazy, your numbers are off, this is a massive system, what are you gonna do? So I think we have a responsibility here to make sure that we're helping our clients get through this process. I'm gonna work on that, but I'm not really engaged in it heavily. I'm just advising on the technical approach of the reporting. But my estimation, when you're talking 20 to 8,000 parts per trillion at 50 feet below ground, you're probably 20 years and 20 million at pump and treat. So that's my ending point, is that there are ways to help the clients get through this. It's not as black and white, and you can see all the different countries have different approaches, and the state has been very, very clever about this, and it's taken their time, and they're working with, top people like Jorge, and I know, Michael, you write a lot of law work. You've done a lot of work with the brownfield side with them to help them. And they listen. They've learned their lessons. So take advantage of that and advise your clients likely, because I think Florida is one of the best states that's working with this. But also, let's represent the industry. Make sure we're doing the right thing and calling environmental lawyers in. So just so you know, it's a real estate transaction. Just real estate attorney. So that's all I got. If I can take questions later, thank you.
All right, we're going to transition from PFAS politics over to the PFAS Analytical Toolbox, I believe. Two gentlemen are going to be presenting together on this one, the PFAS partner in crime. First one's going to be Lucas Barroso-Giachetti. Close? I love that name, Barroso-Giachetti. It's fun to say. He's with Terracon, regional PFAS technical lead, and then Mr. Paul Jackson is the program manager with PACE Analytical for their environmental compliance and emerging contaminants.
Thanks, Chad. And by the way, thanks to the forum for inviting us to participate. We appreciate it. Interestingly enough, Neil's presentation led with the word navigating in the title, and so does ours. But ours, obviously, is about the National Pollution Discharge Elimination System and how that is affecting the states around the country with respect to PFAS. This is a very topical presentation also because, as Jorge reported to us this morning, specific to those of you who are in the state of Florida, House Bill 1019 is currently sitting on Governor DeSantis' desk to sign or veto or not to sign. And one of the sections of House Bill 1019 will compel quarterly sampling of POTW's effluent and biosolids starting this July 1st of 2026. Another interesting fact about House Bill 1019 is that it was unanimously passed in both the House and the Senate in Florida. When was the last time anybody saw that happen? Not just in Florida, but in any state, really. So this is now on our doorstep. So why this presentation? Obviously, Clients are managing PFAS risk right now. This is not news to anybody. PFAS are being added to discharge permits in Florida and in other states around the country ahead of US EPA's action. The discharge testing is evolving. Test methods continue to evolve. These are the topics we're going to cover today: the NPDES system and PFAS, stormwater and industrial wastewater treatment, property due diligence. These sections are Lucas's, and then finally my section, which is the lab side, the analytical toolbox. And now, over to Lucas. I promise I won't trip you up.
Thanks, Paul. Good morning to everybody. I'm Lucas Barroso-Giachetti, so you did a really good job, Chad, with that one. So what I would like to talk to you guys today about is I think we talk a lot about what may happen, but what can happen. And I'm very lucky to be able to practice from Florida all the way up through the East Coast, up into New York. And I just wanted to share some of the things about what is happening right now, right? What's the work that is being implemented right now? And I'm going to touch on three things. One is NPDES, right? We heard a little bit about stormwater this morning. I'm going to talk a little about what to do, what folks are doing to actually treat it, okay? Just as a glimpse. So I don't come from the future, but I do come from the north, if you will. So I'm here to share the lessons from, from the north. And then thirdly, we gathered a lot of clients and said, what are your concerns? What are your questions? Right? We work with a lot of folks that have multi-state, regional, national footprints, right? They manage portfolios. They manage aggregated risk. A term that we're using a lot is the aggregated risk of PFAS. What does that look like? So hopefully after this, you'll have some good examples as to what that looks like. So first, I'm going to begin with NPDES. And we got a lot of questions from clients going, what are these permits going to look like? Okay, I can share with you that in states like Virginia and where I reside now in Charlotte, in North Carolina, they're beginning to look at monitoring requirements for different types of discharges. So this first example is from Alabama. Okay, so for the record, Alabama is north of Florida, so it's still from the north. So this was a wastewater discharge, okay? This is from a landfill, which received some sludge with some impacted PFAS. And they had PFAS added into their permit. So these are only two examples, but an exercise that we did was to see, was there consistency in how these permits are being implemented? The answer is no. There's some significant asymmetry, if you will, as to how they're being implemented. A lot of it has to do with how it's being worded. So we've seen permits that will just say, test for PFAS by 1633, full stop. No list, no recommendations, just that. In this case, this permit did include a list of specific PFAS compounds that had to be tested. They did not include reporting limits, though. And so those of us that deal with PFAS samples and deal with turbidity and TSS issues, we can know that those reporting limits can vary greatly. Another thing that I wanted to mention about this permit, which is another glimpse into the future, these permits are beginning to include PFAS minimization plans or PFAS reduction plans as a permit condition. So the permittees are going to have to show some homework, if you will, as to what actions they're taking to try to reduce their PFAS loads. Okay, so another glimpse into the future. This is a good example from Illinois, and I think it's going to be a good guide as to what the permits may look like. So they're being asked to sample their discharges on a quarterly basis. I think we're going to see a lot of that. I think building on the talk this morning with Jorge and with Michael, and I think building on Neil's point, as Europe begins to look at upstream tackling of the issue, states and folks receiving PFAS discharges are saying, show me what you got and what you're sending me. So this is going to happen more and more. And facilities are going to have to begin to look at where the PFAS are coming from. It's not always intuitive in your stormwater. For example, if you have an industrial facility that has any type of air emissions, it's very likely a lot of those PFAS are on the roof. Okay, and most folks aren't really looking at that air deposition pathway. So what do you do if you have it? And what are folks doing, as far as my vantage point, when they have it and have to do something about it? Whether it's being forced to do something about it, or they're actually doing it on a proactive basis. So let me begin with what is going to be a very common example for those of us that work on any type of airport or in the aviation sector. So this is an example, from an airport that is going to have a very this is a very typical airport story, if you will, right? How many airports look like this? So if you look at my Simon Says looking chart there, those 4 quadrants are pretty much going to tell the story of so many airports and so many airfields, so many operations that have that military history in World War II, post-World War II. Then they get deeded back to the state. In most cases, they have some kind of Air National Guard activity there, and they probably use AFFF per the mil spec. As they get into larger operations, become a Part 139 airport, they're for sure using AFFF based on the mil spec. So this is going to be a very common story, and just like any large operation, whether it's an airport or they're going to have their own stormwater management needs. So in this case, we were asked to help out with the discharge that eventually could impact a source of drinking water. So what we did was to go ahead and design and mobilize what is going to be the answer for, I think, 90% of most of our issues is going to be a carbon-activated system. In some cases, depending on what that influent looks like, you may need a final polishing step, for some of those short chain compounds with an ion exchange. But this is going to be a very typical scenario for so many of us. And I think those concentration ranges are also going to be pretty typical. Okay, so this is a really good example of what I think we'll be tackling. Now, these are airport concentrations. We wouldn't expect that perhaps at an industrial facility, but it shows you that with these concentrations, you can get pretty effective treatment just with very much proven technologies. Okay, so after treating 2 to 3 million gallons, which is pretty significant, it's really operating very well. So I think that's encouraging as a practice and as an industry, that if clients come to us and go, how can I tackle this? Is this going to be complicated? The answer is no. It may not be cheap, but it's not complicated. So let me share with you a couple things based on, so I went out and I reached out to our client community, their legal counsels, and basically asked them, what are you seeing when it comes to property due diligence? And mainly, what are the complaints? I want to hear about what is upsetting you, and what needs to perhaps get better so that that standard of care that we're all wanting to achieve is at least even. So here were the main complaints. Incomplete sampling plans. Either a lot of soil data, not a lot of groundwater data, or vice versa. Lack of co-located locations. So having soil data where you have your groundwater data as you're evaluating pathways, mass, leachability is going to be pretty important. We're seeing too many sites, or I'm inheriting too many sites where you have, and I think it's not surprising, low-level PFAS impacts, certainly in groundwater, okay? I'm in North Carolina. We have very low groundwater standards for PFOA, PFOS, and also Genex, which is a North Carolina PFAS. But in practice, if you don't have a soil and groundwater sample from where you expect the PFAS not to be, it's going to be very difficult. And if you were to enter that site into a regulatory program, you're probably going to have to do that anyways. But you're going to have a much harder time having to tell the story. Okay, so we're encouraging folks, talk to your clients, include the cost to get background samples, and have samples with a purpose. That obviously leads to fuzzy consultant language of I don't know what this means, it's all background, right? And that's not helping folks make quick decisions. And it certainly can be very challenging if you're in a tight IP period. So on the topic of making decisions, I know my dear friend and mentor Dan Schneider was here a couple years ago, okay, to present on the work that we did on this ACRP document. That big old QR code there is a link to the document. It's free, okay? That's the great news about that document, is that it's free. And what we did is, we prepared this document for airports. Okay, they are one of the passive receivers, okay, that are in the conversation there in Congress, and they naturally asked the question, how are we going to evaluate our on-site PFAS versus those off-site PFAS? Okay, these are large properties with lots of shared boundaries, and what is the framework to be able to do this? So it's a great document. It's written mostly in English. There's a couple of chapters that are in environmentalese, right? But that's where we come in. And so, and I'll close with this. We're still seeing an evaluation of PFAS just like VOCs in terms of just totals. So I'm going to say that if the only way to really evaluate these is through multiple lines of evidence. Okay, there's still a lot of hesitation to include radar plots and other ways to look at the PFAS data. Okay, just a simple comparison of what your data looks like in terms of your PFCAs versus PFSAs is pretty insightful. It's not the silver bullet, okay, but it can really help to guide what that signature should look like, and I think it's very helpful. Okay, so lastly, just a quick example. We're helping folks with their wastewater treatment. A lot of folks are looking at what their discharge is looking like and what they need to do proactively. In most cases, it's low levels. So I just want to share this. It's for a site in the Carolinas. And it's just another example of how very straightforward activated carbon, okay, in this case, we did something special. We designed it and built it ourselves. It's a simple trailer-mounted system. I call it the Amazon GAC system, right? So they just call us and, okay, we drop it off. And it's really just for pilot testing purposes. And it's really going to help these clients understand what their full-scale system has to be. So I suspect there's going to be a lot of these at a lot of facilities because folks are going to have to get ahead of this. So, and with that, I'll pass it to Paul.
Thanks, Lucas. So, the Analytical Toolbox for NPDES, Clean Water Act, that's what this all falls under, obviously. And the Clean Water Act lists approved methods for any, not just PFAS, but all the regulated contaminants. And where is that found? That's 40 CFR Part 136. In the lab world, that's what we live by. But how does that affect PFAS? Because there are no PFAS methods in Part 136 yet. Just in the last couple of years, EPA did announce the method update rule, MUR 22, in which it proposed the addition of these 3 PFAS test methods. You can see 2, EPA 1633A now as it's called. That was a change that occurred in the last 18 to 20 months or so. So the original final method was revised again, and this is now the current method. But there's also ASTM D8421, and I want to talk about that for a couple of minutes because not a lot of folks are very aware of that method. Then there's EPA 1621. Well, what is that? That's the non-targeted screening method, as EPA put in writing, for the detection of organic fluorine, ostensibly enabling us to report the entire mass of whatever PFAS might be present, with the caveat that there are other fluorinated chemicals in production and use around the world. But as EPA says, they're in the distinct minority. There's some pesticides and pharmaceuticals. So EPA saw the value in creating a screening method that could potentially impact, especially NPDES. 1633A, 8 matrices it's valid for, obviously, including wastewater, but also biosolids, very important for the NPDES world since over 50% of the nation's wastewater treatment plant sludge is treated in some form and land applied as biosolids for agricultural purposes. Why is that important? Because one of the unfortunate characteristics of PFAS is that they're bioaccumulative. And if the biosolids contain PFAS, the crops that they're fertilizing are frequently uptaking the PFAS directly into them. That's why at PACE we're analyzing tomatoes and beans and other crops every day in addition to things like fish tissue. When 1633 was issued, obviously us PFAS labs had been testing all these other matrices for PFAS for years. Well, what were we doing in the absence of an EPA method? All of us were in the same boat. We all developed lab-specific SOPs. Most all of us, like PACE, became certified around the country in states where there are environmental certification programs for test methods, like Florida and a bunch of other states. This method, over time, is replacing those lab-specific SOPs, commonly called 537M, M for modified. We also use 1633A for top assay. A fairly long list of compounds in 1633, as written, 40 compounds. Some labs, like PACE and some other labs, have written into their lab-specific SOPs to support 1633 internally some additional compounds. But you can see here highlighted in blue, one of the great things about 1633 is that EPA chose to include some of those shorter chain chemicals, sometimes called precursor chemicals, about which EPA has become way more concerned since when they completed their effluent limits guidelines study number 15 in the last few years, they were frequently finding higher levels of long chain PFAS in treated wastewater effluent than in the influent. And that's because of the presence of these so-called precursor chemicals that degraded as a result of wastewater treatment plant techniques. So some of those are highlighted here in blue. 5,3 FTCA is a very common constituent of PFAS found in landfills, for example. So another concern for NPDES. Here's an example of what 5,3 FTCA, its degradation paths, when it breaks down, it frequently transforms into these longer chain PFAS chemicals. One good thing to remember is that 1633 is a performance-based method. That means that under certain conditions, the laboratory chemists can use different processes. We actually had hoped in the lab community that EPA would make these particular two topics, centrifuge and cartridges, during sample prep and extraction a little clearer, but it left them somewhat ambiguous. So it's one thing to be concerned about, or let's just say you communicate with your lab when analyzing samples, especially for elevated TSS, as Lucas mentioned before. There are different things that we can do to prep the samples. We can use a centrifuge, or we can use more cartridges and wider cartridges that can affect the results. Now, the ASTM method. I think a lot of folks in the environmental community may not know a lot about ASTM, but ASTM has been in the test method business for eons, literally. Not just for environmental applications, but many others. And this particular one, D8421, D8535, is a direct injection method that that ASTM improved when it made modifications to D7979. It's a much better method now. It has a much longer compound list. The ASTM version of this method at PACE is actually 44 compounds, not 28, as EPA 8327 was originally written as. It is isotope dilution, and the data correlates really well with 1633. I know you can't read these graphs, but these are comparisons of D8421 in a water sample to EPA 1633, and as you can see, PFOA is right here in the lower left section. The data correlates really, really well. And this is important because the ASTM method being a direct injection method versus 1633, which is SPE, is it's less expensive. And as you can see, there's a cost example here. So if you're on a large scale site, for example, you can collect more data by using the ASTM method. DOD has jumped on this in a big way, obviously big contaminated sites, and more data is good. Oh, sorry, one other thing to mention, especially for groundwater folks, is the ASTM method is a low vol method. We only need 15 ml versus 250 mLs for 1633. And then lastly, EPA 1621, I won't spend much time on it because how it gets used by US EPA is still very much in play. EPA had an information collection request out in the Federal Register a couple of years ago. It's still in limbo, in which it was going to require the nation's 400 largest POTWs to sample influent, effluent for both 1633 and 1621. So EPA, partly because EPA wanted to figure out how to use 1621 in the NPDES system, but that is stuck out there in regulatory limbo. But it is ion chromatography, which we all know and love in the environmental lab world. We've been using it forever for different test methods. But this has a combustion step in it, so it combusts the sample and it drives the fluorine. We absorb it onto GAC, and we wash off the inorganic fluoride, and that leaves us with a single number for the entirety, supposedly, of all PFAS or fluorinated chemicals that are present in a sample to a reporting limit of about 2 parts per billion. So key takeaways, obviously PFAS testing is coming to the nation's NPDES system, including here in Florida apparently in the very near future. Stormwater and wastewater discharges can be treated with cost-effective treatment technologies. Obviously, you want to use your right tools, so select the right methods, the right compound lists, the right reporting limits. There's this great guidance document that Lucas reported on, available to you, and use all the tools in the toolbox to meet your budget, get as much data as you possibly can for your projects. And lastly, there's that House Bill 1019. I keep track of it every other day to see if DeSantis has made a decision on it yet. But supposedly it's coming right down the pike. That's it. Thanks, everyone. Right on time.
All right, so our final speaker is no stranger to the PFAS Forum, Mr. Nick Albergo, with he's senior advisor, I think is the official title these days, something like that.
Old and irrelevant.
Old and irrelevant, he prefers, so with GHD. So, Mr. Albergo.
So my job is to leave you with something to talk about at lunch. How many of you are over 50 in this room? Raise your hand. Okay. Some of you are just freaking liars, too. So you might remember back in the 90s when the conversation shifted from petroleum to DNAPL. We started having DNAPL on the brain. It's a sinker. We got to put in shallow and deep wells. Pump and treat doesn't work. And the reality is it took us some time to learn the science behind DNAPL. And the reality was that, yeah, I mean, perchloroethylene is a DNAPL compound, but if it's way below its solubility limit, it's not necessarily behaving as a DNAPL, even though it might be a DNAPL compound. And so I bring this up because I'm concerned that the PFAS train is running off the track for the same reason, and that's that we're not completely up to speed on the science yet. And it might be okay, as Michael mentioned, we're going to take a pause for a while yet before things get geared up in the assessment world, and that just might be okay for us to kind of get more up to speed on the science. And so I'm serving as the vice chair of the new PFAS assessment and remediation standard that ASTM's putting out. And, you know, it's a learn as you go, as you can imagine, but we've established a number of goals. The first being that we want it to be able to be universally applied throughout the nation the same way. That's always important to a standard. But then we've got some other important goals here. And one is that it's got to be sustainable through whatever dynamics happen on the regulatory side. And one of the epiphanies we've had is that in our standard, we're going to be uncoupling assessment driven by regulatory goals. We're going to separate those two, and I'll talk about that in a moment. We still want to remain loyal to the conceptual site model. That means, you know, sources and release mechanisms, impacted media, fate and transport processes, these are all still and will remain important. But we've got to recognize PFAS as a functional system, and I'll try to define that in a moment. But what I mean by that is PFAS is a non-Newtonian, thixotropic microemulsion. That's a lot in one sentence. But it has time-dependent behavior, and it's got really weird thermodynamics associated with it. And that's why it's used in so many interesting ways in industry and beyond. In general, it's designed to lower surface energy, and that impacts things like viscosity and shear response, which I'll touch upon in a moment. And the benefits of the microemulsions and their stability is directly tied to this low interfacial tension, which is why it's so popular, for example, in the pharmaceutical industry, because it enhances drug solubility and bioavailability. Of course, those are the same challenges we have when we start to talk about it as a contaminant. And so I want to look a little bit further today into the assessment part and hopefully get folks in the consulting community to take a step back from what they've been doing traditionally so far. So I asked this question. You know, if there's a groundwater location where you've taken a sample and you've got 10 parts per trillion, let's just say PFOS, and you got another spot that's at 100 parts per trillion, and there's no weird shit, right? There's no utilities that are causing it to move fast or clay lenses. Would you expect the sample at 100 parts per trillion to be closer to what we'd call a source? And what I'm seeing a lot in the consulting community is the answer to that question would be yes. Well, guess what? That's not necessarily true with PFAS. With PFAS, the concentration is only a part of the story. And the challenge is standard analytical methods don't account for the entirety of the PFAS mass or its behavior, which are going to become really important for us. And that mass winds up being the piece that has the persistence, and it can actually reside at a lower concentration meaning you could miss the source or not understand the source. And of course, if you don't understand the source, you're also going to wind up with ineffective remedial strategies. So, in other words, plume delineation to satisfy a regulator, meaning what's the concentration, and contamination assessment to inform remediation can be very different. We're not treating it that way right now. So what's the role of PFAS? These formulations are amazing. They can stabilize foams and emulsions, control spreading and wetting, prevent phase separation. They take advantage of some really complex science. I mentioned the word rheology. Rheology is the study of the flow and deformation of matter. And it's what allows for the quantification or of the formulation of viscosity, shear response, and this time-dependent behavior I'm talking about. Emergence is a word that's actually stolen from complex systems science, and it describes how the unique behaviors arise from the interactions among these system components. And these behaviors are not necessarily evident when you look at the components individually in isolation, but it does happen when they're combined. And so current PFAS approaches often overlook these behaviors, and it results in inadequate site characterization, inefficient remedial actions, and prolonged contaminant impacts. So how do these things behave? In general, PFAS are synthetic surfactants. They're engineered to reduce surface tension. I'm going to talk a lot about surface tension in a moment, but they reduce surface tension by absorbing at interfaces between air and water or oil and water. They can water attract or they can water repel, but they form aggregates such as micelles, and where the tails form the core of the aggregate, and then the heads are in contact with the surrounding liquid. And this is a generic theme of PFAS in general. So water has a higher surface tension than most liquids, which is why objects with a higher density can still float. Think of like a razor blade, if you've ever seen a razor blade float on water, or if you've ever seen like a water spider, how it actually sits on top of the water with not any of it being submerged. I've got a good picture of that surface tension here in a minute. So let's take FFF, just AFFF as an example, because that's one that people talk about a lot. Here, the PFAS absorbs at the air-water interface, reducing surface tension dramatically, and that generates the bubbles and stabilizes the foam. It actually creates a wetter water, if you will, that more quickly penetrates burning materials, the wood and fabrics and so forth, and enhances the cooling capacity. That's one of the keys of AFFF. It's uniquely effective because the fluorinated tail, if you remember from the last slide with the tails all facing inward, the fluorinated tails exhibit extremely low surface energy, and then the polar heads interact with the water. And it's amphiphilic. That's that idea of a head and a tail, and it allows it to concentrate at that interface, creating the blanket that makes up the AFFF. So when you think about using AFFF on a fuel, on a hydrocarbon, the PFAS reduces both the air-water surface tension and the water-fuel interfacial tension. So it simultaneously stabilizes the foam to form that thin, spreading, gas-tight liquid film that becomes the blanket over the burning material itself. But it also imparts superior sliding properties. It becomes more slipperier than water, and that allows the blanket to unfold very quickly to extinguish much larger areas than the water pressure might otherwise be able to push things. Well, it turns out we can take advantage of these unique characteristics of PFAS that basically allow water to float on oil. Think about it. Right, you normally think about oil floating on water, but when it comes to PFAS, the AFFF actually floats on the oil. It reverses what would normally happen. We can take advantage of those unique thermodynamic properties and the reduction in surface tension as a way to advance site assessment tools in real time on the property, so that we're not taking expensive samples blind, sending them off to a lab, waiting for results and so forth. So I want to talk a little bit about these micelles, these aggregates, if you will. I had already mentioned to you that they behave as non-Newtonian thixotropic microemulsions, but I really haven't explained that. So let's talk about that for a moment. So non-Newtonian just means that there's a variable viscosity, and that variable viscosity depends on stress. So some examples would be ketchup is non-Newtonian, lava is non-Newtonian. Thixotropic just describes the behavior of the viscosity itself when it's subjected to that shear stress. Think about, again, for my 50-year-olds, you remember when ketchup came in bottles? And do you remember how you got the ketchup out as you hit the side of the bottle and then all of a sudden it would start to flow? Well, some of you might have thought that's because you get the air to move in and that's why the liquid flows. That's not why the ketchup flowed. As soon as you affected and agitated, it became a lot thinner, because it's a non-Newtonian liquid. And so that property also exists in PFAS, and it's something we can actually take advantage of and measure. Microemulsions is a whole chemistry in of itself, and it's valued for its stability, and again, this whole low interfacial tension that I've been talking about. And it too carries properties that we can take advantage of when we talk about site assessment. And it's because they form very favorable thermodynamics. For those geeks out there, it has a negative Gibbs free energy. You might remember what that was. So the challenge of the current assessment strategies is that it focuses on a handful of PFAS compounds through standard analytical techniques. And whether we talk about 29 or 40 or 44, I really don't give a shit, right? There's 7 million of them out there, okay? It's a very small group. And the problem is that those analytical approaches, they don't pick up and measure these micelle-bound PFAS or the colloidal structures or these precursor species you heard about in the last talk. You don't get that stuff measured necessarily. That is the mass. That is the source that causes the shedding of the PFAS that becomes the persistence we're talking about. So you can wind up measuring concentrations of these distinct PFAS using these standard analytical methods and completely miss where the problem is. And whether it's 5 parts per trillion or 50 parts per trillion, all those numbers are the same thing. I recognize they mean something from a regulatory standpoint, but they mean nothing in terms of contamination assessment. And so if you look at these monomers, these individual PFAS monomers, these precursors monomers that don't contribute to the micelle, to the aggregates, when they're that way, they actually don't persist. They naturally attenuate. They dilute over time just because they're not aggregated and they wind up floating away and moving away with groundwater flow. And so, yeah, you can still measure them. There's still a concentration, but they're not going to be a risk the same way as where the source is, where all the mass is. That's a great picture of surface tension, by the way, if you were wondering what I was talking about. And so there's some new tools that we got to start working on, and that's what we're doing at ASTM, is we're starting to collect all these new tools that we can use in real time at sites to get information quickly that then could direct where we might want to take samples from a regulatory perspective and get the traditional concentration measurements so we know whether we're above or below or whatever. One of them we can do is total oxidizable precursor assays. You can use that to better understand the unreported mass I was telling you about, the micelles, the colloidal structures, the PFAS monomers, and so forth. But we're still left collecting samples blind, right? Regardless of whether you use 1633 or total oxidizable precursors, you still don't know where you're doing the work unless you know exactly where that spill or that release occurred. And then, of course, in either case, you're still left waiting for the lab results. And so it really does little in either case to address any kind of regulatory comparison, right? So total oxidizable precursors is going to give you a better mass number, but it's not going to tell you individually concentrations, which means you're still going to have to, again, collect even more samples at more expense for traditional 1633 to get those concentration numbers that the regulators want. The challenge is in either of those methods, as I've told you, it's not going to help you with contamination assessment at all. And so I'm watching all these contamination assessments done throughout the country with standard techniques of sampling and reporting, and I'm not sure they know where the mass is, honestly. You know, they're looking at the smoke, not the fire. And so if we can have techniques that are very similar to like an XRF or a PID that measure surface tension, which is a telltale sign of PFAS that has aggregated. That's not these individual PFAS monomers. If we can measure surface tension in real time efficiently on the property, then we can find the fire instead of the smoke. And once we've done that, then we can go back and do the traditional sampling, send it off to the lab, and get those analytical numbers that everybody's interested in. And we're collecting these techniques, and there's all sorts. There's ones with resistors, there's ones that use wavelength light, and can actually be done at a distance above the land where you can see at very low parts per trillion even, where these things might reside, especially in surface waters. But for groundwater, there are measurements that are, instruments that are available to look at the surface tension in real time. So we're collecting these. Another one I saw that was kind of cool was there was a site where they had very low total lead, but very high TCLP lead. And they were using these strong adhesion characteristics that are similar to PFAS and measuring them, and they were able to map where the lead would leach based on the same kind of technology. So I think there's a real benefit in improving our tools and doing a better job in general so we don't repeat the sins of our past like we did with DNAPL, where it took us a little while to figure out the science, and while we were figuring it out, we were putting in shallow and deep wells, and sometimes we were creating the contamination that we were supposed to be measuring by pushing through lenses and doing things we shouldn't be doing. And pause to take a moment to realize that PFAS formulations are not simply mixtures of individually regulated compounds that might peel off in 1633. Rather, they're engineered chemical systems exhibiting very complex properties and behavior. And concentration alone is going to be insufficient to define the source. And of course, at that point, it's very difficult to make good remedial decisions as well. So failure to account for the system as a whole is going to lead to persistent, widespread contamination and ineffective remedial strategies. And so we need to translate what I'll call formulation functionality into engineering metrics. What I mean by that is the state of functionality. I'm just talking about the degree to which the PFAS stabilized formulations have self-organized into these functional structures capable of sustaining long-term environmental release. That's the source area. Otherwise, you're simply measuring the concentration of an assortment of diluted monomers, which may not longer pose any kind of risk at all. And that's the challenge with just running out there taking groundwater samples and simply measuring concentration. From what I can tell, it doesn't mean anything. I recognize it might mean something from a regulatory standpoint, but if we're concerned about the cleanup, if we're concerned about our remedial strategy, if we're concerned about where the source is, that's not the way to do assessment. That's all I got.
All right, do we have any questions? A lot of stuff to think about there.
Hi, this is Paul Hatzinger from Aptum. I had a couple of questions for the last speaker. So you're basically saying, well, let's start with, so at what concentration do these things form a critical micelle? What concentration does something like PFOS form a critical micelle?
It's not, the thermodynamics aren't tied to that.
Yeah, they are. So at what concentration, your chemistry, I'm not sure where your chemistry is coming from, but thermodynamics have nothing to do with that. So at what so you're saying to look at surface tension. Let me just finish my question.
Okay, go ahead.
Because what you're talking about, you're seeming to say that you can look at surface tension at nanogram per liter concentrations of PFAS and see changes, which is not correct.
Okay.
You have to be up in the milligram per liter concentration range or thousands of milligrams per liter to form those micelles, right?
Not necessarily.
You just gave the presentation,
Not
so
necessarily.
tell me what the concentration, PFOA will never form a critical micelle because it dissolves in because the dissolution in water will never reach a critical micelle concentration. So my point is some of the stuff that you just said to go out and look for micelles, these structures that are important, they're not going to be at some of these sites because the concentrations are not high enough to reach those. And in terms of surface tension, you got to be up in the milligram per liter range to start seeing those micelles forming these changes of surface tension. You're not going to see it at nanogram per liter concentrations.
Okay, so let me just respond to a couple of points. In the source areas, you do have higher concentrations. The issue about the micelles and the colloidal structures and so forth, what I'm getting at is they're not measured by our standard analytical techniques. And yet they make up the mass.
I disagree. I disagree that you've got, I think you're proposing a theory here that is not supported by science, that you've got all these things that are in micelles and sources. A lot of these source areas, a bad source area is a couple ppm, right?
Yes.
Okay, that's well below the critical micelle concentration of any PFAS that I'm aware of. And I've got a couple of chemists sitting here, and if I'm wrong, please tell me.
First of all, I would encourage you to join the ASTM committee because we'd love to have as much interaction as possible. So that would be number one. And that's a great place to have these arguments because there are others that would disagree. I happen to be one of them.
Well, are you
and by the way, I'm fine with the disagreement.
Okay, I'm just talking about the basic science of some of these.
Too.
It's in the literature. I mean, it's not.
Yes,
I'm not making something up.
I agree, it is.
But coming here and saying that, oh, you've got all these critical micelles in the environment, and that's really what the sources are. That's just incorrect. There's no evidence for that.
I didn't say.
Well, that's what you said. You're showing pictures of micelles. You're talking about thermodynamics. I don't know what you're talking about there.
In areas where you have the source, the mass, which includes all these things, The micelles, colloidal structures, the monomers, all of those things are, would you agree, are part of the mass? Would you agree with that?
Colloidal structures, so PFAS absorbed onto colloids, is that what you're saying? What is a
Yeah.
colloidal structure in your opinion?
Yes, that's
Oh,
what I'm talking
PFAS
about.
sorbed to a colloid, sure.
Absorptions, yes.
And sorbed to sediments all over the place, sure. I would
Yes.
agree with all of that.
And what I'm saying is that when these things are bound in a way that you're not necessarily going to see them reported in 1633. Would you agree with that?
So in 1633, you're getting them from soil samples, you're getting them from other solid samples. So if you take a core sample along with your groundwater sample, yes, you're going to see those.
But all you get is the individually reported compounds.
Well, correct. I mean, that's
But only the 40 or so, right? There's a lot of others, right?
oh, yes,
Okay.
there are.
So
There's not
that-
7
that's-
million at the
So
site, but
that's
yes. That's where you use the oxidizable precursor assay, correct.
Okay, well, I think we're starting to find some commonality here. So what I'm saying is that when we consider the entire mass of all these things, that helps define the source area where you can expect the shedding and where the persistence lies. And that source area and that mass isn't necessarily measured by our standard analytical techniques.
I agree with that. That's very different than a lot of the stuff you've talked about here, but I agree with that.
That was my whole point, though.
Well, but that's the basic point of using an oxidizable precursor assay,
so
right?
The idea is
absolutely.
The idea is that the mass where the shedding occurs and the persistence occurs is made up of a lot of other things that aren't measured through standard analytical techniques. We can use total oxidizable precursor assays to get a better feel for that mass, right? We can do that.
Yes.
But then if we do that, we don't have the actual concentration of the PFAS, or the PFOA, PFOS that our regulatory people want. So we'd have to do both. Okay? What I'm getting at is there's techniques coming out that we're being given information about that can measure things like surface tension. They can actually do it.
I'm going to stop. It's easy to measure surface tension, but
And
PFAS
at a
at the
level.
concentrations you find in groundwater are not going to change the surface tension. That's my point. At ppm levels, yes. Parts per trillion, no, sir. That's not going to happen. So you're not going to get, there's no measurement. I'm done.
If
I'm
we-
done, Chad. I'm
Yep.
sorry.
Yeah, we
I
should.
apologize. I'm done.
No, I love that kind of stuff.
No, this is good. It's good. It was good.
I love that kind of stuff.
You go well, though.
Okay, well, I'm not a chemist, so I got a simpler question. Are there chemicals that are often found, in the family, maybe daughter products or whatever, that are less reactive, that are more prone, or maybe might be better candidates for using traditional methods of plume chasing, where the high concentration is near the source? You know what I mean? Like other chemicals found within the family that would be less.
So there's a lot of different AFFF formulations out there, and they are extremely complex in terms of the chemicals. And the other things that happen is these things can oxidize in the presence of chlorine or other things, even some natural oxidizers. And so, yes, there probably would be. I'm not sure measuring them is going to get you any closer to knowing where the actual source is.
Well, I mean, if you get a rundown of like, hey, I've got 40 chemicals here, and of the list of 40 of them, this one's pretty darn inert compared to the others, couldn't you use that to track it?
That's a lab.
This mic is working? Okay, good. The only thing I'll just offer to try to answer that question is that test method development continues when it comes to PFAS, because thousands of PFAS chemicals out there. TFA, great example. I think a lot of folks believe that TFA, which is in that category of PFAS chemicals known as ultra short chain chemicals. I've seen some reports that estimate the TFA is the most widely used PFAS globally. We cannot detect TFA in EPA 1633 sufficiently well. So labs like PACE and some of our competitors who are here as well have developed lab-specific SOPs for that very purpose, to detect ultra-short chain PFAS like TFA. I don't think that directly answers your question, but
It does, it helps, yeah.
Okay, but all I'll say is that this will continue to evolve when it comes to PFAS detection.
Okay, thank you.
All right, so my question goes back to the Senate Bill 1019, or House Bill 1019. I know that that is going to be directly related to wastewater for biosolids and effluent disposal. Are we also looking at that falling under the guidelines of industrial wastewater as well? Or
No.
Okay.
That the legislature, the language in House Bill 1019, in fact, for both the AFFF section, but especially for the wastewater discharge and biosolids section, is very vague.
Yeah.
But it makes no mention of industrial discharges.
I was reading through it myself, and that's why I was kind of bringing this up in the general forum, is right now industrial wastewater is not being required for any type of monitoring or required treatment or anything else at this point, correct?
In this state.
Okay.
It is in many other states.
Okay, thank you.
Anybody else? Like we're wrapped. Oh, here's one.
Nick, I really appreciate the information you're bringing to the forum. Thank you for doing that. Question for you is, have you discussed this or floated this with any regulators? Have you had any conversations with DEP or any of the local agencies like Dade County, for example?
No, and part of the reason is we're just not ready yet. So we're in the early stages of collecting these other techniques that might be able to be used on property. They exist, they're trademarked, they're patented. So we're in the process of collecting them, vetting them, putting together the science in a coherent manner for a standard, with the idea being that once that's done, we can kind of take it out there and see how it plays. But right now, we're just in the midst of the data gathering to put it together.
And last question, have you attempted to apply this theory to any of your own sites, any of your own client sites, to see how this plays out? Have you verified any of this in the field?
I have not applied it personally, but that's because I really don't get involved in that detail anymore. But the people that are coming to the committee have sites where they have used it and it's worked well.
Thank you.
Any other questions? I hear some stomachs grumbling out there. Everybody's ready for lunch, and Mr. Jones.
Yeah, first off, if everybody give this panel a round of applause, thank you very much. All right, so lunch is going to be in Signature 1. So back by the escalators where the restrooms are, just keep walking down that hall, and that's where lunch is going to be. You're going to collect your lunch ticket from the back of your badge, okay? Thank you.